Okay, testing. So, hello all Form 4 students. Here today, I would like to bring you the main concept about the chapter 9, the rational functions. So, recall yesterday, I gave you the exercise in Form 2 consolidated exercise 4A to practice about how to simplify the algebraic fractions. No matter you are doing addition, subtraction, or even multiplication, division, you should remember some rules when you do the algebraic fractions. But the most important thing is that in Form 2, your math teacher did not highlight that the answer should be factorized. So when factorized, factorized means that in the final answer, both numerator and denominator should be factorized. So here I would like to remind you once again is that answer should be factorized. That means that, for example, if you have some term that you can take out the common factor, so you have to take out common factors in your final answer in both numerator or denominator. So actually before you have to simplify them, but after that you have to take out the common factor. But you may ask, oh Mr. Wong, why Form 2 teachers say we were not unnecessary to do so, but in Form 4 it means that in DSE we need to do so. It is because when we talk about the concept of rational functions, because we want to highlight the factors among the numerator and the denominator. So we need to show all the factors that you can see in the fractions. So we need to take out the common factor in order to provide that you are factorizing the polynomials on both numerator or denominator. So do remember is that factorize your answer is very important. So today I would like to give you a very easy concept. If you still remember that we are talking about that in this session we have 9.1, 9.2 and 9.3. Actually 9.2, 9.3 are very similar to what I said yesterday, because we just want to do more about algebraic fractions, but now we will go to another word to say rational function. So I will tell you in the next clip. But today I just want to tell you a very easy concept. It's chapter 9.1. It's talking about the highest common factor and the least common multiple. So do remember is that these two words are not unfamiliar, because you have learned these two words already when you learned in primary school. Because if you still remember, we will say highest common factor. In short form English, we will call HCF, and the next one LCM. So I mean these two words are not very difficult to you if you still remember in primary school. But now we would like to highlight that we are not only talking about HCF and LCM, but we want to talk about HCF and LCM of polynomial. That means that we want to talk about if I have some algebra, so how can we find their HCF and LCM? So especially when we talk about the polynomial, so we have to talk about in this clip. So you can also see that in my notes I will say that the title is HCF or GCD, so you can see the word GCD also, so I will tell you why. And the LCM of polynomials. So here brings to you what is the meaning of the highest common factor or HCF and the least common multiple of polynomial. So actually, do remember is that from now on, actually in primary school, some math teacher may tell you also is that HCF we have another name, and that name will be more common in general math book. We will call greatest common divisor, or in short form we will say GCD. So why do we have to use the word HCF before? Because I don't know why. I haven't checked the history yet, but I know that I think that it is because of English writing, because you understand that Hong Kong before is the colony of UK, so many things would follow UK system. So HCF I think that is also one of the words from UK, but in general we will call the GCD greatest common divisor. So why do we use the greatest? Because greatest should compare with least. If I say LCM is least, so the opposite should be greatest, not highest. So I don't know why it's called highest, but anyway. So no matter we talk about HCF and GCD, they are just the same. So you have to remember is you need to just remember the word HCF, or we simply say GCD, and the next one is LCM. But how do we use the concept of HCF and LCM into polynomials? So we can take a look to the example 1. So you can see that in example 1, for each part, you have 2 polynomials. Okay, so please remember we just do the polynomials. What does it mean? That means that if you have something like 1 over x, or with something like square root x, these two are not considered because they are not polynomials. So we will not talk about any things, HCF, LCM, about these two things. For example, these two. We just talk about the polynomials. For example, we say that A, you can see that now for the first one, you have x to the power 4 bracket x minus 1 square, and then x, and then multiply x minus 1 cube. So we will say that in order to find HCF, LCM, so we have to remember what we learned HCF, LCM before. We learned these two by finding the numbers. So before you find them, you have to factorize by writing in prime factors. So for polynomials, we are doing the similar thing. Is that in order to find HCF, LCM, so what we need to do is that we have to divide the factors of each polynomial in groups. What does it mean? For example, for x to the power 4, x minus 1 square. So we can say that here you have two different groups of factor. One is belong to x, so you can see x and then the power 4. The next one is x minus 1. That means that in this polynomial, we will say that x and x minus 1 are two different groups, the polynomial. So what the difference is that you may have the power on it. For example, here, x, you have the power 4. So I use another color to highlight that. Okay, this is 4 here. And x minus 1, you have another power is 2. That means that in order to find HCF, LCM, so what we need to do is to first of all to distinguish different groups of factor. For example, we will say x and x minus 1 are totally different because x can never be multiplied by the same term or similar thing to becomes x minus 1. Okay, if I multiply the polynomial. So we will say that x and x minus 1 are different. So on the other hand, you can also see that for the second polynomial, x times x minus 1 to the power 3, you will have also these two groups of polynomial, which are x and x minus 1. But you can see this time I have different power. So I use another color to show you. For example, here, x, you have the x. So we say that you can write in power 1. And the next one, x minus 1, is power 3. So in order to say the HCF and LCM of these two polynomials, so what we need to do is that we have to do group wise. That means that we have to do group by group. For example, we first of all to consider the x group. So you can see the x group for the first one, x to the power 4, x to the power 1. You have the second one. So what we need to do is that when we talk about the HCF is the highest common factor, okay? But instead, in polynomial, we have to take the lowest power, just like before. So it may be a little bit little bit confusing to you, because when we talk about h, you may think highest, you may think the greatest, just like GCD. But do remember is that it's just opposite. For highest common factor, we have to take the lowest power. So just remember the reverse, okay? So after you have watched the clip, so remember a very important thing is that reverse, okay? HCF is to reverse, to take the lowest power. That means that on the other hand, when we talk about the HCF, LCM, we have to take the greatest power. So what does it mean? That means that what we need to do is that now we have to see which power would belongs to HCF, which power is belong to LCM. For example, you can see in this group, x to the power 1 is the smallest power here. So we say this one is for HCF. So why? You can see when we say the answer, we write x instead of x to the power 4 because we have to take the lowest power here. That means that for the x to the power 4, it belongs to LCM. So you can see in the LCM, the first term you multiplied will be x to the power 4. Then after you have finished this group, so you go to another group and then do the similar thing. For example, x minus 1 square, you go to HCF, x minus 1 cube, you go to LCM. Then what you need to do is that you just multiply all the things with HCF, LCM, then we will call the answer. So why you can see that it is very easy. What you need to do is just to compare. You just compare, okay, group by group. Take the lowest power to the HCF. Once again, lowest to HCF, greatest or highest to LCM, just opposite. Then we will have the answer. Very easy. For example, we take a look on the B also. For example, you can see this time B, instead of groups of polynomials, you also have numbers, for example, 8 and 12. So in order to do this, okay, what we need to do is to do also group-wise. But for number, you just do what you learn in primary school. That means that for number, you find the HCF and LCM among the numbers themselves. For example, you know that for 8 and 12, the HCF should be 4 because you have to take the greatest factor for 8 and 12. So you take 4. For the LCM, you need to take the least multiple. So we have to say 8 and 12, the least multiple should be 24. That 24 can be divided by both 8 and 12. So we have to check 24 here. So remember, number, you just do like what you learn in primary school. But for polynomials, you have to do group by group and follow the rule as I said. Lowest power for HCF, highest power for LCM, then it's finished. But you may say, oh, Mr. Wong, this time there would be a special thing is that now you can see the x squared just only appear in the second polynomial. You cannot see any x grouped things in the first polynomial. So how should we do? So do remember is that if you can only see the x in this one, so actually this first one, you can also make an artificial x power to it. What's mean artificial x power? That means that it is not natural, but I intentionally make it. For example, here I can make the x. But in order to make this polynomial still valid as before, so this one should be x to the power 0. Because you know that x to the power 0 is 1. And 1 can also be anything power 0, even if you say the polynomial. So we will say that now I can say this one is x to the power 0. So you can still compare the idea using HCF LCM polynomial. Because x to the power 0 and 2, you just take the smallest power, the lowest power. For HCF, it is x to the power 0. That means that here, it should be x to the power 0 artificially if I want to make. But you should understand that x to the power 0 is artificial and it is equals to 1. So you have to simplify it to make it cancel. Okay? That means that HCF is still valid for using the lowest power for HCF and greatest power for LCM. Even some terms is absent, okay, among these 2 or 3 polynomials. But still you can make the power 0 on it to make it in HCF. So after you understood the HCF, so having an LCM is just straightforward. Okay? That means that the idea of finding HCM and LCM is easy. What you need to do is just you do numbers by number, polynomials for polynomials. Among the polynomials, you do group by group. Okay, you do group by group. And then you take the lowest power for HCF, greatest for power LCM. That's it. So this is actually the main idea or the only idea you need to learn in this session. So we go to take a look for a few more examples. For example, this time you can see that in example 2, now you have 2 quadratic functions, 2x squared plus x minus 6 and 6x squared minus 7x minus 3. So you can see that there are no factors, no brackets given to you. So you need to remember is that if we do not give you any factor, so you have to find the factors by yourself. That means that no matter what you need to do, you should first of all to do the factorization. So that's why I said why we have to always factorize the thing, because this chapter actually is to ask you to factorize and then to see the characteristic or see something common within the factors. Okay, so what we need to do is that first of all you factorize using cross method or any method you used before, but you have to show. For example, you show me that 2x squared plus x minus 6 can have these 2 factors and so on. So for this one, this time you should see very carefully, because now you have 2x minus 3, x plus 2 for the first one. For the second one, 2x minus 3 is common, but you can see 3x plus 1 is new. That means that this time when we talk about the HCF and LCM, so we have to divide it into 3 groups. For the first one, you have 2x minus 3 and then x plus 2. For the second group, you will have with the second polynomial, you have these 2 groups, 2x minus 3 again, and then 3x plus 1. So do remember is that now, because we have no power, or we say the power 1 on each factor, that means that if I just want to say the HCF LCM, because all in the power 1, so what we need to do is just you have to take what you have in HCF and LCM. For example, you can see both, okay, have 2x minus 3, okay. So we can take 2x minus 3 to the power 1 or simply 2x minus 3 as HCF. But you have to see that because x plus 2 and 3x plus 1, not all polynomials have. So you should have some power 0, so power 0 will not show because it's 1. So you can see why HCF you just only have 2x minus 3. Because we just take those we have common, okay, in HCF. If one absent, you will not put it. Just like we say power 0, you should absent. But for LCM, you have to include all polynomials to take the lowest power, okay? So to take the highest power. So remember is that you have to take the highest power for LCM. But this time you can see all the power is power 1. So what we need to do is just very easy. You just put all the factors into your LCM. So this is the answer. So why you can see is just as simple this way. So I would like to say that these are level 1 questions. So we have to take a look on some level 2 questions also. For the level 2 questions, actually the difference is that I may give you the higher power polynomials. For example, you can see this time P, you have x cubed y, power 4. And for Q also power 4 because you can see y to the power 4 as well as x squared y squared. So you can see these two terms or even the middle term 4x y cubed are also in degree 4. So all these two are in degree 4. So but what you need to do is to be careful is to factorize. So you can see for P, you factorize as y, x plus y, x minus y, x minus 1. And then for Q, you have y squared, x plus y, all squared. So you can see that the groups would be divided in this way. First of all, y and y squared are in the same group because they are originally from y power. And the x plus y and x plus y squared are also in the same group because x plus y to the power something. So you can see y HCF we just pick y and x plus y because these two only common in both polynomials. For x minus 1 because you cannot see them in Q, so we will not put in HCF. Okay? But for LCM you have to take the highest power. That means that you can see y we have to take y squared and x plus y squared instead of 1 because LCM is to take the highest power. So you have to include square here. And then x minus 1 should be included also. But you can also see that for polynomial Q, you can see there's a number 2 here. So these two you cannot see in P. That means that the number for P is 1. 1 and 2, the LCM, you still need to take 2 here. That means that the concept of HCF LCM is not difficult. But what you need to do is just you should be very, very careful when you take the power. Okay, remember for LCM, you take the highest power. HCF, you take the lowest power. For numbers, you do using the way before. So there's a difference here. Okay. And then for the example 4, I think that it's just straightforward. But do remember is that sometimes, because we are talking about to factorize the polynomial, so you may be sometimes relate to the things you learned in chapter 6, the polynomial. For example, the factor theorem, or you have to factorize using the long division. So what the things you need to use maybe chapter 6 again. So do remember. And I will not give very detail about this example, but this one is not actually very important. So before I end the clip, okay, this time I give you a very short homework. So even you say, oh, Mr. Wong, there are 8 questions, so many. But I would like to say these 8 questions actually are not too heavy. Okay. So the homework would be exercise 9A. Okay, exercise 9, your book. Question 9, 10, 11, 14, 15, 16, and then 24, 25, 8 questions. So do remember is that you do not need to write so many steps for these 8 questions because actually for the question 9 and 10 you can just read the 2 polynomials and then you get the HCF LCM directly by just taking the powers. Okay, so very easy for question 9 and 10. For the other questions, sometimes you may have to use the cross method or you may have to use the factor method or then to long division. But do remember practically in DSC you do not need to show me, okay, how do you do the cross method. Okay, because what we need to do is just you show me that oh you are going to the cross method, then this is your method that you are using. Okay, this is enough. For long division also. That means that for doing the remaining 6 questions, you may just write the answer after you have written the steps in your rough paper, or you may show the steps is okay, but you don't need to write so many steps here. I expect that for this 8 question, you may use only up to 2 pages of single line paper. Okay, up to 2 pages, but I think that this 8 question I can finish within 1 page, of paper. Okay, not so heavy, but try to see whether you really understand what the book want to tell you and what I want to tell you. Okay, so try to do your homework. Keep the healthy day. Okay, see you and goodbye in the next clip.